always been and will always be. Every particle in your body has always been and will always be. You and I won't, but those particles will. And it was Einstein and his E equals mc squared that discovered in these particles vast amounts of energy. And Stephen Hawking, when he was talking about all of this coming down and imploding, and incidentally, right here at the Big Bang, he said everything that we see, and incidentally, I can remember from Physics 101 in college and undergraduate school, the professor saying, if you take a basketball and you put it on the ground, and then you get a golf ball, and you get in your car and you drive a mile down the road and you sit it on the ground, you're looking at the proportions of the particles inside of an atom. The basketball would represent the protons and neutrons. The golf ball would represent the electron, the negatively charged particle. And, aha! That's a lot of space. That is a lot of space. And so, if you go back, Stephen Hawking said that at this particular moment, and it wouldn't have been but a fraction of a second, hardly a nanosecond, everything that we see out here in the cosmos would be no bigger than the end of your thumb. And it would implode on itself. And it would start all over again. So when you look at the pressure in here, at one point, they estimated that the pressure inside the Big Bang, at the point of the Big Bang, would have been 10 to 20,000 tons per square inch. They have recalculated that, and now they're saying the pressure inside of that was 1 followed by 72 zeros, tons. That's a lot. Now, why am I mad at Stephen Hawking? Because he, in Brief History of Time, or when he's talking about the universe in a nutshell, I think he is trying to take us back to his first book, where he's saying everything. I mean, the end of your thumb could fit inside a nutshell. This is a walnut. And that is mind-bending, mind-altering, staggering. But it's only been in the last, I think, 25 years that they now see that because of the laws of thermodynamics that you have the Big Bang and the Big Crunch, and this is the way. I mean, Stephen Hawking, in A Brief History of Time, gave 5 or 6 different theories on how this occurred. How we started out with a Big Bang supposedly, got to the Big Crunch, and a new Big Bang, and a new Big Crunch, and it's going on, and going on, and going on for, and this is the symbol for infinity. It has always been, and will always be. In the world of physics, there is a term that they use a lot. And determinism is what creates. I mean, we were just talking about the first law of thermodynamics. If there is a singular exception to the law of thermodynamics, it is not a law. So when you're looking at the laws of physics, you want to either validate them or you want to find the exception and come out with a new theory and look to science to have it either validated or eradicated. And come up with a new theory to explain it, etc. Because that's what science does. And that's what Einstein said at the end of his life. Einstein said that the only truly religious person was a scientist. Because, yeah, they may believe it, but then they're going to set out to prove it. The idea is to come up with a theory, but then you use science to prove it. The whole idea here of determinism, in 1827, there was a botanist by the name of Robert Brown. And Robert Brown was looking at the reproduction of plants, and he dropped some pollen in a glass or a petri dish or something, and particles started shooting out everywhere. And so what developed was what has come to be called the Brownian motion. And it is now, I think, evolved into what's called the uncertainty principle, which they want to use to modify determinism. That, yeah, you may have all of these laws of physics, but there may be the exception here. And if there is an exception, then we need to rethink our laws. Well, the uncertainty principle, my attitude is, and they have not come up with the equation or sets of equations, and incidentally, today I hope you appreciate the fact that I have followed Stephen Hawking's position in A Brief History of Time, because Stephen Hawking was told when he was writing his first book, that for every equation that he put in the book, he would cut his readership in half. So he was trying to put these great ideas into terms, and I haven't come across anybody that has understood all of this. And if it seems like I'm trying to make you think I understand all of it, I don't. I think I understand maybe 70% or so, but there's a lot there that I don't understand. But in considering Brownian motion, considering the uncertainty principle and modifying the laws of physics in a deterministic way, my attitude is this: if we look at infinity, infinity past, infinity future, if there is no such thing as creation, if we're only discovering what has always been there, you know what? 1,000,000 years ago, was there the potential for understanding E equals mc squared? It was there. It was just discovered. Was the idea for television always there? We all know when it was discovered. But we, in the limitations, I think, of language, and the average person does not get the privilege of thinking like the physicists that are here, that get to think in mathematical terms that are more precise. I mean, you go back to Sir Isaac Newton. Principia de Mathematica, in which he talks about gravity, and I think he's been proven to be wrong, and we may get time to talk about that in the next 10 minutes. Determinism in the uncertainty principle, I think we simply have not discovered the theory that is going to produce the equations that can, in fact, predict the direction of these particles. It's there, we just haven't discovered it yet. Just in the same way that Einstein discovered that the only way, and when I was young, I looked at mass times the speed of light, and you end up with pure energy. But I never focused on the pure energy side, and especially from the standpoint of infinity. Einstein, he says in the Universe in a Nutshell that he was wrong here. That black holes do not reduce themselves down to a singularity. He was admitting he was wrong. So I thought, darn, I thought I was just beginning to understand that. And he's now apparently saying that these particles, as they're entering these black holes, that somehow the protons and neutrons are separated from the electrons, or these quarks, etc., and all of what we now call quantum physics and quantum mechanics. And in other words, now they're delving into the microcosm. And I think this is more complicated than this. But I'm agreeing with envy on just how smart these physicists are. But anyway, Hawking says, basically, that black holes just keep going and going until there's nothing left. And they keep, and he has discovered that around these black holes, if here's the lip, and it goes down like a funnel to a point down here, and around the lip is called what they call the event horizon. And you're beginning to get close to traveling at the speed of light, and the speed of light squared. But one of the additional things that they're apparently discovered in the last 20 years is that these particles somehow get separated as they're going in. And one reason why Star Trek was wrong when it had that guy that was going to go through a black hole. Once you're in there for a week or two, you're getting close to being nothing but pure energy. And you'd probably be no more than the size of a piece of spaghetti. And you would be traveling so fast. Can you add something to that? He's smiling, and I know he's a very bright man in the physics department, and if he can help y'all out to maybe correct some of my statements, I don't mind at all. And anyway, but in the black hole, apparently now they see it as not going down to a singularity. And so I've got to revamp my thinking, and I don't quite know how to put it in, because after reading brief history, I saw the black hole as where you got down to the singularity, and that it was the singularity, so now there's something else that's got to create that singularity. Figure it out for yourself. Einstein, once he got, and he produced 5 essays in 1905. The first 2 had to do with molecules, and the last 3 had to do with relativity or relatedness. And everything is related. You and I are not only related, but we're related to all living things, like Albert Schweitzer saw once he understood relativity back in 1905 when he went into medical school to become a medical missionary, incidentally. And so Schweitzer could see the relatedness of all living things, and that's what he was concerned with. But actually in the world of